So thank you very much. My name is Szabolcs Rodek. I have been working here in BlackRock for almost the last 2 years. And what I prepared for today is a presentation about doing some refactor on Angular application that utilizes components that have lots of similarities, but that have lots of differences as well. And as an example application, I just implemented a pretty simple one. It just shows you 2 material data tables in the front of your face with almost the similar functionalities. The only difference is that they have different kind of data present, and different kind of actions to apply on the entries, on the rows, on the elements of the table. Of course, the actions don't really do anything any interesting because it's just an example application. So if you are really interested, they are logging something in the console. I can show you this. But at the last presentation, the audience just said that they didn't see anything about it. But yeah, I just show you just for the sake of clarity, especially if I can open it. So the only thing it does is just logging to the console that what action has happened. Basically, the log itself is running at the higher level component, at the application component. So all the events are bubbling up to the higher order component, to the root component. That's pretty important because without it, it wouldn't really make any sense to show. All right, let's dive deep in it. Let's jump in it. First of all, I have to tell that I won't gonna dive deep into the implementation details of the application. And I have 2 reasons for that. First of all, it's not really about Angular, this presentation. This presentation is much more like about how to refactor UI, let's say object-oriented UI code. And secondly, I have time limits, unfortunately, and I want to reach the end. And second statement before I start the presentation, that I don't have any slides, any PowerPoint slides or anything like that prepared. And I had 2 reasons for that. First of all, as I said, it's really a code-based, it's really a technique-based presentation. And secondly, I felt that it would be too rigid for me because I'm not that experienced speaker than the previous speakers, before me. So that's my reason for choosing this format. All right. So as you can see, we have 2 tables here with pretty much the same look and feel, but different kind of data and different kind of actions. And if you take a closer look, they have different kind of formatting regarding to one fields on each table. The first table, the business client table, has a date formatting here. The second one has a currency formatting here. It's just just a side note. It's not that important. I just wanted to mention because it's gonna be part of, I don't know, the later part of the presentation. So the format of my presentation, before I really jump in, is basically walk you through on a refactor process of Angular components that has really similar aspects. And I'm gonna walk you through by 4 steps. First step is actually the starting point. Is just a basic implementation of that application. And during the next commits, the implementation is changing a lot, but the look and feel are gonna remain the same. I'm not gonna build all the commits for you now because it will also take a lot of time. But trust me, the only difference is just the implementation itself. And at the end of the day, we are gonna kill almost all of the redundancy from our code, and it's still pretty functional, and it's still pretty easy to read, easy to improve, and so on and so on. First of all, I just would like to show the root component template because last time I got a critic that it would be nice to see that what's actually going on at the top of the application. So as you can see, It's really just two material card items with two different tables in it. That's pretty much it. All right, first of all, please raise your hands if you used to work with Angular. Okay, I would say half of the team used to work with Angular. I want to ask if you work with TypeScript because it was asked before, and I memorized all of the faces. So, so no worries. All right, it's really just the showcase that how was the application, how did the application look like before the refactor. So this is the implementation, the implementation of the business clients table class. This is the logic behind the table itself. As you can see, it has an input, a property, which is a list of entities. Here, it is a specified type called business client. And this is just a list of them. It has two output events which you can emit if something happened and you want the root component to let know about it. It has a getter which returns with the list of the columns you want to display at the table. So basically, it returns with those column names. I need this because I didn't want to follow the official, recommended style of implementing material data table because it's pretty verbose and it's pretty impossible to generalize. So I'm gonna show you in a nutshell that how does the template look like. But again, it's not the most important part. It has two pretty important properties as well: the list of the actions and the list of the columns. The list of the actions basically are the actions that gonna be emitted by the menu item clicks. Like if you hitting that button, then this one is going to emit an action. That's it. And the columns are basically just some metadata for the column to be able to display it in a right way. As you can see, it has some logic in the ng-on-init lifecycle hook. For the people who are not aware about Angular lifecycle hooks, this function, this method is invoked right after the component had been created at the Angular, basically. And besides that, it has another method which is going to be invoked when the click happened at the lower level components, and it has two private methods. I don't want to be that verbose. The following part of the presentation was that verbose now because I just want you to let you know that what is the base implementation, what is the verbosity that's going to disappear soon. If you take a short look at the other table component, it's pretty much the same. It has the list of entities, it has its actions, it has the displayed columns getter, it has the same stuff in the ng-on-init hook, and it has totally the same, private methods, almost totally the same. I'm gonna take a look at the differences soon, but it's almost the same. And just as I promised, I just show you that how does the template look like. This markup is serving the purpose of the possibility to make it general in an easy way. So instead of having thousands or tens of containers with the column details in it, it really just iterates over the metadata of the columns, as I described before, and just renders all the necessary information to the table. I don't really want to spend too much time in it. Let's just go to the first round of the refactor. And as a first round, I wanted to create a base class which has all the properties which are pretty obvious, let's say, which are pretty obvious and which aren't going to change in the future probably. Why I'm saying that? Because inheritance is one of the worst patterns, in my opinion, in the object-oriented design. If we are talking about, sharing some properties, sharing some functionalities between classes or between functions or between anything. So you should have your really serious reasons if you want to use class inheritance. Why I'm telling this? Because class inheritance has, which you probably know, has a couple of drawbacks. First of all, it has the problem of fragile base class. What does it mean? Once you created a base class, which is going to be the ancestor of lots of different implementations, you are not really allowed to change anything in that base class, because if you do, you can break your whole application, or you can cause a pretty big amount of refactoring work, pretty big amount of rewriting the implementations, the child classes. So because of that, if you decide to create a base class which you are going to extend later, you should really be aware of this rule, that you shouldn't put anything into the base class which is going to be changed in the future, or which you think is going to be changed in the future. The second problem with inheritance, and I'm talking against myself, I know, but you'll understand later the reason. Second problem with inheritance, especially in JavaScript, I think, which is not a class-based object-oriented language, and it was never a class-based object-oriented language, is just a syntactic sugar, especially with TypeScript and with its pretty strong and pretty fancy typing system. So the second reason is the problem of the bananas and the gorillas, which is, let's say, kind of a funny or cute saying, something like that. You just wanted a banana, but you get a gorilla holding a banana and the entire jungle with it. What does it mean? It means that probably when you implemented some base class, and it's much more true if you have a big class taxonomy. In this example, it's not really going to be the case because I don't have any big chain of inheritance. It's just one base class, one implementation. So it's much less dangerous, but still. So what does this banana bullshit mean? This means that you can have a lot of class members, like methods, like properties, which are probably pretty useful for lots of the childs of the base class, but in lots of cases you will end up having methods and properties in your child classes which aren't going to be used, which are just there for nothing, and in the best case, they are just there for nothing. In the worst case, they are just there for breaking everything and make you really angry. Sorry, I'm a little bit nervous now, but it's all good. The problem is even bigger if you used some dependency injection in the base class. Especially if you use more dependency injection. And if the injected dependencies also have some dependencies, the problem just grows and grows and grows, and you end up finding yourself in a pretty verbose, pretty big, compiled code. Even if your class is just tend to be some pretty simple implementation. But still, if you know about these drawbacks and you are brave enough, you can utilize the class inheritance in Angular, especially because it's a pretty class-based framework. But as I said, you should put only the things here which are pretty simple and which are not going to be changed in the future. What are those things? First of all, you had the list of entities. Instead of having a specific name, I just call it entities, and it's going to be implement the type T. It's going to be a list of T elements. What does this T means? T basically is a generic type. I'm quite sure that the most of you are kind of aware of it. It basically just means that if you have a generic typed class or a generic typed method, you can use this function or this class with a variety of types instead of just one. So if you remember the previous implementation, it was it's in the case of the product table, it worked only with product, typed objects or entities. In this case, if you're gonna extend this class, it's gonna work with any kind of entities which are extending the entity class. The entity class is pretty simple. It only has one ID property, which is a string, and that's necessary because of the material, table implementation. I think it's not that important from our point of view. And same for the actions. It implements the generically typed menu item, which is a list of actions. And here comes the much more interesting thing. Here is the display and columns gather. So if you take a look at the previous implementation, they are not pretty much the same. They are totally identical. So it returns with an array of the columns names with an action, with an additional action which is necessary for the action context menu. So this is something you can generalize. Same goes for the onItemClicked method. The only difference with the previous implementation and this is just that your payload has a T type instead of a specific one, and it has an item which also a T typed. The only thing which is a little bit more, I wouldn't say complicated, but is a little bit more interesting, is that column factory and the get cell renderer. So the column factory is, again, it's totally the same as it was before. The only difference is the generic type T. But for that column factory, to get it work, you have to have a get cell renderer method, or it's a property, not a method, doesn't matter. It's a federal function at the end of the day. But this get cell renderer is going to have a little bit different implementation across the child classes. So because of that, instead of defining any kind of implementation here, you can use an abstract keyword, an abstract modifier here, and with this you don't have to implement anything, but you can reference it here in your other method. So why I made this abstract? It's pretty simple because I have two different dependencies for the two implementations. The first one has the currency pipe, as I showed before, and the other one has the date pipe. And I didn't want to inject both of them to all of the implementations because, as I said, it would cause the problem of the banana and the gorilla. And of course, at this scale, it doesn't really matter. It really doesn't. But the goal of this kind of refactor is not that having some almost good solution. It's pretty much to having the best possible solution that you can have. And just as a showcase, the only thing changed from high level is instead of referencing to the entities as product and as business client, you reference this input property as entities, as you saw before in the class implementation. So this was the first part of the refactor, and this was the longest one, to be honest. The second one addresses the thing I told about the drawbacks of inheritance. So we have a lot of problems with inheritance, and I would never suggest to use it, except of this, of course. But if you're not using inheritance, what would you use? What are your other opportunities to solve some problems, to modify some classes behavior or anything? Here's another object-oriented pattern called composition, which is a little bit different. So what is the difference between inheritance and composition? It's I would say it's pretty easy to explain, but not that easy to understand. So the difference is the relationship between the ancestor and the child. If you are working with inheritance, the relationship is a relationship, which means the child is a parent. For example, if you have an animal class and you have a dog class, which you extended from the animal one, then you can tell that dog is an animal, which is pretty much true. I mean, in my experience, it's kind of okay. But if we are talking about composition, the relationship is going to become can do or has a. I pretty much like to use can do. What does it mean? You can create some functions, some pure, easy to read, easy to consume, easy to reason about functions, which describes that what can an animal do, just to stay with the previous example. For example, animals can eat, animals can sleep, animals can hunt. Not all of the animals, but okay, let's just accept it. And if you want to create a dog, you can compose those functions into one object. Right? This is how composition works at the end of the day, in a really simplified way. How do you do this with classes in TypeScript? Here's a pretty exciting and let's say pretty new feature in TypeScript. It's that new that you cannot really use in a production-ready JavaScript code, because in JavaScript, as far as I know, it's not supported yet. It's just an experimental feature. In TypeScript, you can use it. And what decorator is basically? Decorator is just a function that changes the behavior or just observes or totally recreates a class, a method, a function, or a property. We are going to examine, or we are going to take a closer look into class decorators. First of all, before we take a closer look at the implementation, how to use it. Here, I wanted to implement a displayed columns decorator. Why I wanted to do this? Because if you remember from the previous implementation, you had this gather. And for this gather, you had to, give me a second, just. Yeah, so with this gather, you really had to create the columns array with this column factory, which I think doesn't look that bad, but totally unnecessary to have that kind of initial, definitions in your code. You can solve this by function composition, because the functionality is going to be the same across the implementations. Just in a nutshell, what does this function, what does this method doing? It just returns with the material column typed object, and the name is going to be the name, and if you give another parameter, it's going to be the type of the column. The type is just only important because of the different way of displaying data. For example, here the type is the date, here the type is the currency. It's just this is the metadata, and you can decide that what kind of displaying settings or options you want to use. And instead of this redundant implementation, I decided to create a decorator, which is going to solve this problem for you. So how does it work? This is a decorator factory, which means this function is going to be invoked with a list of strings. Those strings are going to be the name and optionally the type of the column. And here are some really pretty simple functions. First of all, the getName function, it checks the column parameter, or checks the column string, and it splits up the column to to an array by using a comma as or a colon as a delimiter, and takes the first element of it. And the get type does the same, but it takes the second element, and if it doesn't exist, it's going to be a simple string. And then it returns with the function. So this is the decorator itself. This function that's gonna be returned here. What is this target? This target is basically the constructor function of the class. And this is the biggest difference, I think, between the decorators in TypeScript and the decorators in other, let's say, object-oriented languages like Java, like Python, like C#, like whatever. Because here, the constructor function is the function that's gonna tell that what the class is, but it's not really a class, it's just a function that has a prototype, and you can mutate or you can change that prototype in a way you want. So as you can see here, I create the column times array and make the prototype.columnTypes property equal to it, and afterwards I doing the same here as I did in the getter, if you remember. I think it's a pretty easier to read this way, and especially if you take a look at this implementation here, you don't have to take care of those column names, displayed columns and columns anymore. So I can show you the other implementation. The situation is the same. The only thing remained for us is the actions array here, which we have to create. And yeah, I have to show you that some pretty small change happened here. I created a set columns method, which basically creates that column here. I not created, I moved that set columns from the implementations to the base class. So with this in mind, your class implementation just became even smaller. And here is the third step, another type of decorator. It's pretty different than the previous one. What is the difference? With TypeScript decorators, if you are talking about class decorators, as I said, you can observe the class. It does pretty much nothing, just logs some data, logs that the class has been created, that the function has been invoked. It can log that, what kind of properties it has and such. But if you want to modify the class itself, you have two choices. First of all, you can have that kind of factory function that I showed you before, which just returns with the constructor function with some changes applied on it. But if you want to if you want to reference the methods or the properties or anything about the class you want to decorate, then you have to return with a new class which extends the constructor. So okay, this markup is pretty hard to consume. I'm going to send you all over the implementation. You can take a look at it. It's not that scary as it looks like for the first look. I just needed this to make sure that everything is going to work. For example, the supercall. Without this type notation, it wouldn't really work. So what you should do if you would like to reference the properties or the methods or anything about the class you want to decorate, you have to return with another class which extends the constructor function of the class. How is it possible? Because, as I said, in JavaScript there is no class. After compilation, there is no class at all. It's just a syntactic sugar. There is going to be a constructor function because in JavaScript, the object-oriented way of doing things is not done by classes, it's done by object prototypes. So with this in mind, you can extend this constructor function which implements this interface. And if you call the super with the arguments you get, you can reference all the properties of the class you are decorating. What's happening here? If you take a look at the previous implementation, again, sorry for moving that much across the screens, but the thing I want to show you is that how to reduce the boilerplate code, how to reduce the unnecessary code, and because of that, I have to go back sometimes to the previous, commit. So in the previous implementation, there is an array of actions which you have to create. What is this actions array? It's just the metadata about the actions going to be emitted. If you go back to the table implementation, as you can see, here is a view, here is an edit, and here is the delete action. It has a name, it has an icon, and it has a callback, if I remember well. Yeah, exactly, it has a callback. And you have to create that array of actions on ng on init hook, or this is your last chance, because if you don't do this, and if you don't make it, you don't make the actions array at least with an empty array, then your application is going to fail to compile. Not compile, but fail to run. It's going to drop you an error. All right. How would I solve it? I'm going to wait a list of parameters called action items. And this action items is going to implement an interface of a name, of an icon, and of an event name. And the name and the icon are pretty familiar, but why is this event name necessary? This is necessary because I want to reference to my output events by their names and emit an action and emit an event if it's necessary. But for that, I have to reference them in a dynamic way. As you can see, I don't know in runtime, and especially I don't know in build time that what kind of what's going to be the name exactly of the output. So I have to reference them dynamically. And because of that, I just implemented a small check, because if you're gonna give a wrong event name that doesn't exist on the class implementation, which is that one. So if you would type here, for example, viewed instead of viewed, it's not going to give you any error. I can show you this in a real life if you give me a second. So here's our product table component. I don't know if you can see it. So if you take a look at it, it accepts that list of objects as a parameter. If you just make a small mistake, it's not gonna be underlined by TypeScript because it's not an error. It just accepts a string, and you don't know that what kind of list of strings can you use here. But if I save it,
Szabolcs, sorry for interrupting. We're running short on time.
okay, this is the last 5 minutes. Sorry for that. As you can see, it just failed to run and threw an exception that there is no output property called viewed defined. This is necessary because you want to avoid this kind of actions, but this kind of errors. And if you didn't avoid it, it can make your hair destroy from the top of your head. So that's pretty much it. It returns with that kind of list of objects. And if you take a look at the implementation, it's pretty much thinner. The only thing you have is the cell renderer. And as I said, I'm going to keep this here because of the dependency injection, because I want to avoid everything, because I want to avoid the problem of the bananas, as I mentioned before. The case is the same regarding to the other component here. And last but not least, I just wanted to show you as a final step that how can you completely avoid template redundancy. Because in Angular, especially if you are working with material table, but almost any kind of component, it's a pretty annoying thing that you have to repeat yourself in your templates. Of course, there are a couple of ways to avoid this. For example, you can create child components. You can have a template here with the child component and such. And you have a couple of other ways. I'm not gonna dive deep in them because I have no time. But instead of this, I not create any template for the implementations of the base class. Instead, I create one component, which is going to be a shared one, which is a pretty simple one. It just accepts the list of entities, the list of displayed columns, the list of actions, and the list of columns, and it has this template. And as I said, it behaves pretty much in the same way than it did before. And what's the trick? I just implemented a new service which can create the component and apply on the Vue container you provide to it dynamically. How does it work? You just make a company factory resolver, dependency injection, and an injector, and you just have to implement a method here with a parameter of the Vue container. That Vue container is going to be the Vue container that holds the table implementation. So if you take a look at here, this is the base table. This is the abstract base table which we started to use. Here is the dynamic component series I just created, and the creation of the embedded component is pretty much this. You call the append component to host with the Vue container reference of that component. And how do you provide the data? You just I just implemented another method here, which accepts the list of entities, the actions, the columns, the displayed columns, everything you need, and you just provide it. It does pretty much the same, or it does the same as if you would put it in a template with the template markup. Sorry for being that long. I didn't want to be that verbose. Forgive me, I'm a little bit stressed. Thank you. I hope you enjoyed. I hope you learned something, or I hope you learned anything from my presentation. I'm gonna send you over the implementation of this small example application. So please check the meetup page, because I'm gonna leave it there as a comment.